In this recording, we're going to learn how to do basic trinomial factoring. So trinomial means, prefix here tri meaning 3, right? So we've got like 3 wheels on a bicycle means tricycle. So we're going to try to break apart a trinomial, like the one here, at the middle of the paper, into its factors. So it's one of those really critical skills in algebra. Let's start by getting a little prerequisite, sort of like a warm-up here, going in the opposite direction of factoring, which is multiplication, putting it together rather than taking it apart. So let's set up our window together. Of course, we're going to put our factors on the edges. Those are like our dimensions. And you're going to write your products in each of those panes. So go ahead and do that. Play the recording when you're ready. Okay, so if you came up with these products. Now we just combine like terms, which are usually on the diagonals. All right, so there's our product. Can you go ahead and work out part B and C? Play the recording when you're ready. Okay, so if we work these out, if not, please pause and do so. Me doing it is not the same as you doing it, all right? All right, so the process of factoring a trinomial is basically to go in this direction. That's what factoring means, to break it apart into its two factors, its things being multiplied, okay? So let's figure out how we'll do this thing. We're given here a trinomial, x squared minus 3x minus 28. Just like above, we're going to start out with a window, except we don't know what's on the sides. We don't know the dimensions. We do know what's inside. So we're going to place our x squared here and our minus 28 there. Those are always the placements for our squared and our constant term. The question is, what are the two terms here? We don't know yet. But we do know is that they're going to add up to negative 3x. Okay, remember that? We always do that in our multiplying. We add on the diagonals, and those are our like terms, right? They add up to the middle term. Negative 4x, negative 2x, 4x, and 2x. So back down to the example we're working on. We're trying to find two numbers that are factors of negative 28, but they add up on the diagonal to negative 3. So you're going to get good at this. You're going to develop some skill with practice, where you don't always have to list out all the factors. But for now we do, because we don't know them all yet. We're not quite comfortable with the process. We're just starting to walk here. So we list out all the numbers that multiply to be negative 28, because those are the only possible numbers I could put on my edges, right? That multiply. Sorry about my dog there. Need two numbers to multiply to be negative 28. So let's look through our list and see if we have any that add up to be negative 3. So, yes we do. So right here we have a factor pair that adds up to negative 3. So that means, of course, x squared is going to be x and x. And then we've got the factors 4 and negative 7. Those are going to be the numbers in either order that multiply to be our negative 28. Let's put in our middle values to see if it all works. I've got a 4x, negative 7x. Yep, sure enough, those are going to add to be negative 3x. Okay? So now what's our answer? Remember, it's going to be two binomials, two binomial factors. Well, those are our edges. Those are the x minus 7 and x plus 4 that are on our edges. Let's try a couple together. So this first example, let's first start out by making our window. Okay, we'll place the x squared in the top left. Already I know its factors, x and x. And then we'll place the 6 in the bottom right. I'm not sure about its factors because it's not a prime number. It has, let's see, 6 and 1, Just make a quick list. 6 and 1, -1, -6, 3 and 2, and its opposites, -3, -2. So I'm looking for the pair that adds up to 5, right? Because I know these have to add up on the diagonal to 5x. So 3 and 2 seems good, right? I'll put those up top. So I've got a 2x and a 3x. All right, now I need to check it. Do those add up to be 5x? Yes, they do. So then my factors are x plus 3 and x plus 2. All right, I'd like for part B, you to get as far as you can. Set up your window, put as much in there, list your factors out of 14, and try to find the factor pair of 14 that will work to make a -9y. Play the recording when you're ready. Okay, so hopefully you made some progress here. Y squared here, 14 here. Make a list for my 14. 1 and 14, -1, -14. I think that's it. So I need a pair that adds up to -9y. Well, I've got it right here. So I'll put my y's on, and I'll go -2, -7. Let's check it. -2y, -7y. Yep, those will add up to a -9y. We've got our factors. Sort of checking it as we go, right? Because the window already shows the multiplication. And we know that the multiplication, these terms all combine to be this original trinomial. All right, for part C, I'd like you to go even further on your own. See if you can do the whole process on your own, then play the recording when you're ready. Okay, so hopefully you did that. Okay, so I have all my factor pairs of -18. I need to pick the one that works to add up to 7z. Right? Any of these I could put on my edges and they'll multiply to be -18. But only 2 of them will also add up to 7z, and hopefully you chose that pair right there. Try to make your z not look like a 2. I put a line through the middle of mine. Last example. This one's a little tricky, right? Because it doesn't have that middle term. Let's get as far as we can, and then when you get stuck, we'll play, right? Go ahead and play the recording after you've gotten as far as you possibly can on your own. Okay, so hopefully you got at least this far. You listed all your factor pairs of the constant, the number, and you've got your x squared and your -4. Now, one thing to notice here is this is also known as x squared plus 0x minus 4, right? There are no x's here. So I need these 2 terms to add up to 0. I need them to be opposites. Well, that should lead you to recognize, hey, I got to pick this last choice here, right? 2 and -2 multiply to -4. They also add up to be nothing, right? They're opposites. They cancel each other out. So they add to 0. So 2 and -2. And then we can write x minus 2, x plus 2. This has a fancy mathy phrase we call difference of 2 squares, because this is a square, and there's a minus sign inside. You can abbreviate it, difference of 2 squares, dots. Thanks for watching.